Very warm welcome also from my side. Thank you, Quentin, for introducing me here. It's such a nice setup here in Killarney. First time I'm here and hopefully not the last time, so really appreciate this. I would like to talk to you about 5G connected services for cars, what this actually means. I'm going to take you into the fantastic future world of 5G. We're going to fly high in the sky to see, what this all enables us, or in our terms, we press the pedal to the metal, go 250 kilometers on a motorway, right? But being there high in the sky does not really help us develop the business. So we're going to go into soft landing, and we will look into what technology can do already today, connecting very well to what Barry and Quentin actually discussed here, to really see what kind of value we can already create in these days. So before actually getting into this one, I would like to show you a short video that shows the power of ultra low latency communications in autonomous driving. It also comes with some nice music, so enjoy the following one here. So what you just saw is based on a project we did together with the Technical University of Dresden with Frank Fitzek. And a lot of thanks goes to him for doing that and writing the software. You may have noticed this has been done in 2016. So this is already 2 years old. So 5G in 2016, what was that all about? I can tell you, this was just plain LTE, but the big difference is what you saw when the cars were moving slowly and when they were going fast. The big difference between the two was just to add the edge cloud and to get the latency communication between cars into very reliable and low areas. That's the difference. So, but first, let's look a little bit into 5G. 5G is going to be the revolution of the communications as we know it today. It's going to be the communications between peoples, between things, and it actually brings a completely different world in 3 dimensions. First of all, it is extreme mobile broadband. What we will see is actually that beams, radio beams, will follow us on the way, will follow the cars, and will pump data up to 10 gigabits per second into moving objects. Absolutely stunning what is being developed there, but also very cumbersome. So this massive broadband is the one thing, and this is maybe the one that we also know very much from waiting for a video on the smartphone. Forget about this, it's not going to happen in the future anymore. But the second thing that actually comes is the massive machine-to-machine communications. If we now talk about connecting just everything, what 5G will bring is 1,000 times the number of pieces can be connected per square kilometer than what we have with the technologies today. So that will actually cause us, our clothes, our phones, our shoes, our houses, that's all going to be connected at the end, right? We are preparing the networks for this one. Last but not least, it's the critical machine communication. And a critical machine is very well known also as a car, right? So these machines will communicate to each other with very low, ultra-reliable 5 nines, 6 nines latency and reliability. That's what 5G is designed for. We're doing this to create big value. So I mean, this is the estimated value creation of this new, everything's being connected world. It's an estimate that has been done by McKinsey, and it predicts what the value is in 2025. We're not talking about billions, we're talking about trillions here. But what you see is there is an estimate between the low assumed value and the high assumed value. The magnitudes are just big, right? I mean, what that means is we don't have so much of a clue, but we assume that the numbers will be big. It's going to be in factories, in cities, logistics, automotive. I just named the few that are really relevant for us. There are also other areas like remote surgery and health and these kind of things, but this is the most relevant for us. It's going to renovate the cities. It's going to change the way how we produce the cars in the factories. It's going to change the way how the cars drive. That's the hypothesis. So, before now going into a really practical automotive example, I cannot save you from spending 1 minute of time on the architecture that will be built. And this architecture consists of two things. So one thing is a new radio technology, like we know it from LTE. That is the communication through the air interface from a phone, from a car, from a device to the network. So that is a big change, and we have 10,000 of engineers actually here in Nokia working on this one because it makes all of this more fast, more efficient, and just improves the performance by magnitudes. So one thing is the radio. The other thing, which is actually a little bit simpler to achieve, is the architecture. So it's not that only the air interface changes. 5G means a completely new architecture. The networks that we will see, they will be extremely scalable. They will be automated, they will be self-healing, they will configure themselves, and when you have a need, they know how to address this. We use AI to implement this, but the networks itself will be intelligent. There are three more things. They are here in blue, which are very relevant now when we talk about automotive. Let me go through these ones. The first one is these networks will be cloud native. What that means is that the big monolithic clouds that we see today, that Simon, for example, has shown in Bosch, right? These will come down into the neighborhoods. Every base station will contain a cloud, a local cloud that builds, many, many millions of clouds that are distributed all over the planet. People speak of these clouds like fog, right? There's also the word of fog computing, so the cloud will come to us like fog. The next thing is, it's going to be AI-driven. So in these clouds, you will have AI algorithms, you will have accelerators for AI processes to really process, understand data, and apply artificial intelligence algorithms to that data. So the fog that comes to us is intelligent. And last but not least, the fog is open. Open here means that we put some Docker type of architecture in there so that you can take every software piece, put it into a so-called container, and run it on this network in your local neighborhood. And open also means that even an undergraduate information science student nowadays knows how to put his software on this architecture. So that means everybody will actually have access to this cloud, being able to generate value directly in your neighborhood, directly where it matters. That means in the areas where cars are driving, for example, where people are moving, where entertainment needs to be done, you can go onto the cloud and add value. That is what open means here. So, the last piece I want to show before we actually end on what 5G really is one concept I still need to introduce to you, and this is the concept of network slicing. When we now will have all these 5G networks in place, it's going to be a lot of physical infrastructure that builds this network. This one physical network, we will be able to chunk into millions of logical networks, each logical network being a closed network on its own with own parameters. You can, for example, have a local network with ultra-low latency, low throughput, and high security. Or you can have a nationwide broadband network with 100 megabits per second on a best effort basis. Because of AI and the self-configuring version of these networks will be actually available at your fingertips, at the fingertips of all companies in a minute, right? So you can hook on a web interface to say, I need a network slice, for example, in Killarney, for this event to provide a service to these participants here, and the parameters that I need are these 4. So you order this one, you can immediately use it, and you can even watch the parameters as you go, right? Control that what you actually buy is exactly what you get. This is network slicing. So what does this mean for automotive? Of course, looking into what I just described, these platforms, these intelligent platforms, they should be the best platform for increased safety, for highly autonomous driving, to run actually the software and the algorithms that are required to proceed on this journey, right? You're going to have network slices to address telemetry service. You need to download a new software version to all of the cars, just configure network slice, download it, boom, done. Should be no issue anymore than what we see today. Finally, we also going to have, of course, much more time, as Barry already said. So how do we spend the time? I mean, we're going to sit in the car, we're going to, on the way to work, we're all going to have a first WebEx session, we're going to be in virtual rooms, being almost present in there. We're going to surf the internet, we're going to watch Netflix, we're going to have haptic internet, where we can even, touch the clothes of the stuff that we want to buy. All that stuff, wow, right? That's unbelievable what I think is waiting for us. Now comes bad news and good news. The bad news is, what I just described will still take a lot of time until we get it, right? The 5G, even though it is hyped up right now, the deployments will be such, it will come to the cities first, it will come where the people are, and the first services that we will see will be smartphone services. Getting the bit to the phone cheaper than currently, and more bits. This is what makes the business case right now of the telco industry. The industrial business cases, they will follow thereafter. We are talking about 2021, 2022, and then we still have the problem that a nationwide deployment will take a lot of time. I've seen strategy slides that look into 2025 until this 5G new radio has come. That is the bad news. Now, what is the good news? The good news is we don't necessarily need this fantastic new radio technology. What we need is actually the right architecture and leverage the existing stuff, right? With this one, we already today can add a lot of value, which I will show you now in the remaining part of my presentation, giving the practical examples. So when we talk about 5G new radio, what cool stuff that is, here is actually a comparison between LTE and 5G. What you see is that on the most relevant parameters for automotive, like mobility, network latency, and reliability, the difference is not that big. We're talking about a factor of 10, where, for example, in the data volume, we're talking about a factor of 1,000, right? So LTE already now can give us 4 to 5 nines, can give us 20 milliseconds latency car-to-car communication, and can do 250 kilometers per hour, enough for German motorways, right? So we are already in a pretty good position. So we don't have to wait for 5G. It's a very important message here. We actually demonstrated the value of the existing technologies just now in a joint project with BMW, where we took an existing network and we chunked this into 5 slices, which we then applied to public safety and to automotive. What we actually had is one slice for autonomous driving with very high reliability, low latency, always there, as good as you can get it. We had one for HD maps distribution, of course different characteristics, a bit more capacity is needed, but it doesn't matter if it comes now or in 50 milliseconds, so a bit more relaxed on the reliability side. Then we had one slice for infotainment, kind of best effort. And then we had, just to show the concept, we had one slice for video surveillance where we connect a couple of cameras, just to have some important camera observation traffic there. And then there is another slice, the slice number 5, which is the emergency slice. So in case that in a certain area an emergency comes, you just build this network slice instantaneously, right? It just takes a minute. and then the first responders hook onto that network and are able to communicate. What we actually showed in this demo is, first of all, these slices, they can coexist, and the highly autonomous driving always gets the priority that it deserves. Even when you then temporarily in that area have an accident and you build a very important network for first responders, always the highest importance, right? Still, the very important highly autonomous driving survives this one. So you compromise on the right stuff. The infotainment, of course, will be compromised, right, in that case. So this can be built. It's just a matter of taking existing networks, adding edge cloud, and a little bit of software, and this can be done today. So continuing a little bit on what is available right now, this has been shown today a couple of times, because the edge cloud is not yet really deployed. So the only thing that right now we really have is we use 3G and 4G networks to connect the cars to the backend systems, right? I mean, all new cars, now they come with a subscription. They pump up the data into the backend clouds, and they create value for the industry. My car, for example, if the rain sensor says switch it on very heavily, and for 20 seconds it gives a message to the cloud. In the cloud, they actually see a couple of cars telling me that this is actually happening, so I think it's raining there heavily, and then we can actually warn all other cars getting into this area, it's going to rain heavily, right? So these are the basic services that these days you can do. Not critical in terms of latency, but already adding a lot of value. The other thing that we see here is actually a network slice. It's called narrowband IoT, which is a technology designed to penetrate deep into cellars and buildings, where you can use, for example, to find your car in parking houses when you have these mobility services like Drive Now and these things, right? So that is already existing. Now the next thing that will come, that is actually in 2020, we will see cars communicating with each other with LTE, that is called the LTE V2V. For that one, Qualcomm and the other chipset manufacturers, they are now building dedicated chipsets which implement this technology. It was defined in the release 14 in 3GPP, and we will see mass deployment of this technology in 2020, allowing cars to communicate even though there would be no network around. This is only short-range communication technology, gives you maybe 200, 300 meters, but it's going to be there. However, we don't actually have to wait for 2020 to really do that, because when we now change the architecture of the network slightly and add the edge cloud, that means, a couple of servers every, let's say, 20 kilometers. Doing that one, you can already do this now. You just use the existing LTE connectivity technology in the cars. You have the car talk to the cloud and have the cloud talk back to the cars. Using this one, you get 20 milliseconds guaranteed latency and communication time from a car to a car. And it's always 20 milliseconds, right? It's not like in the internet, you wait for something and you cannot predict how long it takes. This is going to be 20 milliseconds car to car. This is what you can do, no problem. So this is cars talking to cars. The story continues. You can also have car talking to infrastructure, what we call V2I, and we have cars talking to passengers, what we call V2P. Here, same thing applies. There may be dedicated technologies for direct communications, car to infrastructure. DSRC, for example, is even available in the market, but not selling like hot shit. However, what you can do is use just the existing LTE connectivity to the network at the edge cloud, and then you can have direct link from a car to a traffic light, to an automatic sign, to roadside infrastructure. 20 milliseconds latency guaranteed. Same we see with the passengers. Will passengers carry a separate device to make themselves somehow visible to the cars? No, I think it's going to be the smartphones and applications on the smartphone which allow them to be visible for cars, right? And this we can only achieve if we use the existing stuff, if we connect everything tightly together using Edge Cloud and build it. Technically doable. And this I show you now in the following. So just summarizing what the new architectures can bring us. They can bring us low latency, high reliability services. They're going to be a platform for local data aggregation, open for everybody, right? Remember the openness concept here. So the software that you put into these networks, the life cycle of this one will be independent from the life cycle of the networks, right? You have full access, full control over it, and you can just plug it in wherever you need it. The technology can be used to leverage the standard LTE that we nowadays have in the cars, so no additional investments needed. It's basically a matter of software at the end that needs to be done here. So this is really the power for applying, edge, cloud to the existing networks. This is actually what this can do for automotive. So we have built it. What we see here is a piece of German motorway, which is called Digitales Testfeld Autobahn, a wonderful German word, actually. And this is a piece of autobahn, of motorway, between Munich and Nuremberg, which is stuffed with technology. And what we have done here is we have collaborated with a German operator, Deutsche Telekom, and we have taken 8 of their base stations and connected it to 2 edge clouds, right? So exactly putting in place what I just showed you on the previous slides. The network is a live network, so we are on the same network where people are being served with their smartphones, where cars are connected for making calls. It is really an existing live production network. On these edge clouds, we can actually change applications as we want, and we have used a lot of different partners, like we've worked with Continental, with MHP, with Hexagon, with Audi, to really test and verify the value that this really creates. And we are doing this now since a little bit more than 2 years. We have implemented several use cases, automotive use cases, like emergency warning, end of jam warning. There is variable speed limit adjustments, download of HD maps. There was connectivity assisted lane assist, and there was precise positioning. So quite some use cases that we implemented there. And I mean, the sky's the limit. It's a matter of effort, and it's a matter of getting the ecosystem together to really start adding value here. With that said, here is one very practical example that I would like to put in front of you. And I already mentioned it on the previous slide. Precise positioning was one of the things that we actually worked on together with the ecosystem. So right now, if we look into the GPS functionality of a car, the precision of this one is above a meter, right? 10 meters, 1 meter, varies a little bit depending on the conditions. But this is what you get currently with the commercial GPS receivers that we find in the cars. So how can we improve that one? We scratched our head, and what we actually figured out is there is a so-called reference architecture system, which takes in satellite data, and where at certain locations, every 50 kilometers, you have receiving stations from these satellite signals, and out of the satellite signals, they actually calculate a correction factor that you can use to improve the precision of the GPS. So we connect this reference network to the edge cloud, and then locally to the area where the edge cloud serves the cars. These correction factors are then broadcasted to the cars in that area. The cars receive these factors, and then it is just a matter of software in the car to use the factors, use the signals from the GPS, and you can improve the precision of that system from more than a meter to less than 10 centimeters precision. And this is what you see here on the right-hand side. All the green areas were the ones where the precision that we found was below 10 centimeters. And that should be actually enough for highly autonomous driving. There is a couple of things like bridges where you see a couple of faults, when for example, this broadcasting doesn't really work. So these you need to fix. But generally, deploying precision of 10 centimeters in GPS signals is no rocket science. Can easily be done. It's just software. Coming to an end, we also do this not only here in Europe. We are doing pretty much the same in the US. We are also in China, in Japan. The architecture is always the same. We are working with different car OEMs on this one. The value that we always see is just enormous, and we just would like to now really get this kick-started and do something. So, in summary, I showed to you how cool 5G really is, right? But hey, let's remember, the existing stuff, if you beef it up a little bit, is also extremely cool and really serves the purpose. It meets the requirements in terms of low latency, of high reliability, and it's ready and easy to deploy. Just take the existing stuff and bundle it together. What we need to solve to really do that, we need to actually work on the ecosystem. There's going to be car OEMs, road operators, telcos, politicians. All this needs to work together, come hand in hand to really bring the technology together. It's going to require business models to really do that, as we said. Are we now paying for security? What fees can we think about? Who gets what is the value chain? That's really complex. And then finally, we need to follow the dynamics on this planet, right? China is now pushing like crazy. They are much more easy on the regulations. They have decided for a technology. They push, push, push. US also. Europe is lagging a little bit behind. Happy to fix that. Thank you for that.